we had a ton of new things that no one had ever tried before. And we were, blank slate, green field, go to town. And oh, look at this cool stuff no one ever thought of. We could do this, we can do this, do this. Well, pretty soon you get a bunch of things that looked good on paper. Many of them worked, but a lot of them had bugs because they're way more subtle than you would have thought. So it was another 2 years to beat the bugs out. Here. So, oh, people piling in fast now. Arthur Campbell. Yeah. So the question was the early history of HotSpot. How long to go from having Sun shipping a thing with like an interpreter only to HotSpot being useful? And I was saying 1 year it was running benchmarks well and people were excited, but it was too unstable. 2 years it was stable enough for early adopters, but you still could find bugs that crashed the system or places where the compiler gave it up or generated really, really poor code. And it was another 2 years, so 4 total, before the thing became stable enough that sort of mainstream folks started piling in on it. During that time, the client...
What year would you say that was?
Well, I joined Sun in '96, but I was immediately told, go make a jet, except in emergency, do something stupid with the existing system when I did a bytecode rewriter to help it. So probably '97, I started in earnest on the jet. And 2 years later, so, 99, 2000, it was stable enough for early adopters. Yep. And being the frank guy that I am, like I have strong opinions, but I'm willing to back them up with all kinds of facts and history. The prior guys tasked with writing the jet, so not the runtime, but the jet, were unhappy. Let's put it that way. Politely, they were unhappy with what I was producing. And so they petitioned to go produce what is now called the client jet. And I thought, what a great way to get these guys that are a pain in the neck off my back. Go to town, dudes. I know what the code quality you're going to get, and you're never going to catch me. So, because I'd done things like that before. It's a useful technology point in JIT code generation, but it never hits the C2 style. And so away they went, and then they petitioned because they played politics better than I did and got client made the default, even as C2 was stable enough that major Sun clients running Sun hardware were like confused when the default changed from, had been C2 for about a year because there wasn't a client. The client showed up, but the client was much slower. So there was a lot of history there. And it was another like 2-3 years, like I almost left or was leaving when the server became the default again. And it was a stupid thing. It should never have not been the default, but I was not playing politics. So call it 2 years to being useful and 4 years for production ready.
Hey.
And I think I've run over my starter time, so let me get 30 seconds to do this thing here. My lawyer made me say this. Right, so this is Coffee Compiler Club. Anything to do with coffees, compilers, language, runtimes, garbage collection, multi-threading, concurrency, typing systems, yada, yada, all fair game. Open mic, I reserve the right to moderate, never had to do it. You're being videoed even right now. It's going to go live on Twitter in, a couple hours to a couple days, according to my whims. That's it, go to town. And somebody had a question that I interrupted to say my legal spiel. No one's going to admit to it now?
I have coffee.
Excellent. I do not. I should go. I drank mine already. Too fast. So I'll throw out my 2 bits of status report. I finally, am in earnest integrating Hindly-Milner and forward flow typing, and I'm 3/4 through my test cases, and it seems to be working. Not obviously far enough along to say total victory or anything, but I think I'm going to get it. And after that, I can go at any amount of detail you want in there, although I don't have any prepared anything.
Had any fun bugs?
And all kinds of fun bugs. I don't know what you mean by fun bug. I only have fun bugs. There's always things going on there that are surprising that you don't know until you don't know them or something, till you fall over them the hard way. I am extremely aggressively asserting sanity during this phase. So like, it's a small step execution model or operational model. I have what I believe to be the correct state of the world involving everything is monotonically improving. And so all values are computable from their current inputs in the graph to a new value, which is monotonically equal to their current stored value. And I'm checking this invariant across the whole graph at every step. So that's quadratic immediately. The same is true for the Hindly-Milner typing, because I've broken it down from a single pass tree walk into a worklist algorithm, which is definitely unusual. I picked up a new version here. So that has turned, so half my bugs are what I call progress bugs, where I have failed to record that progress is possible in order to maintain the invariant that if you can make progress, you're on the work list. And then half the bugs are something stupid where, you know, I fail the ups and the downs and the monotonicity and stuff. So the place where Hindly-Milner interacts with flowing is at call sites where Hindly-Milner does application sites. Hindly-Milner does an exciting thing where they do this, make a fresh copy of things and do a unification. I've done a bunch of stuff here. See, this guy changed his email. There he is. I do a bunch of stuff there that's sort of different than Hindly-Milner in implementation, but in theory it's the same. And that's to avoid making an entire clone of things for the fresh copy I lazily created on the fly. So that was some bugs to work out.
So you mentioned a quadratic runtime, and you seemed like you were disappointed in that, but Hindly-Milner is exponential.
Yeah. So right. So back up here for a second. I'm throwing an assert on every node in the graph at every small step. So I am asserting at a quadratic level of complexity, and it shows. Like I turn that assert off and I run my tests with a much smaller set of asserts, and it's much faster as expected. But when I'm doing like major debugging on things, I do this small step, assert the entire graph, small step, assert the entire graph. Okay, so now then there's Hindly-Milner, which I heard you say exponential, and I went and read all the papers, and people are believing it's not that bad, but in practice, it rarely ever gets there, and you have to try really hard. So,
yeah, right. I've only seen contrived examples that make it exponential. I've never seen it in practice, not even close.
Right, exactly. So at the moment, I don't have these contrived examples in front of me, and I'm not even going to try it. I don't care. If it's in practice, it's running in linear time, I'm all happy. Now, having said that, I've taken a number of shortcuts in places that the algorithm obviously allows that may defeat some of the exponential patterns, but I don't know that I've actually done an asymptotic improvement on Hindly-Milner. Like I yanked the SSA piece out, the piece where he discovers lexical scoping, because I've done that already. So that simplifies the program a bunch. And then, as I said, I lazily manifest the fresh copies at application sites, which means that many times I never actually manifest it at all. And that would be an asymptotic improvement, but I don't know that I have asymptotically done it everywhere that's necessary to actually change the asymptotic timing, right? So I clearly have a more efficient algorithm in theory. In theory, though, it may not be asymptotically better, right? So that's sort of that state of Hindly-Milner. And then what you're saying about exciting bugs, it was Hindly-Milner interacts with flow typing at application sites where Hindly-Milner will demand the return of a call be not equal to the merge of the function inputs, like a function site. If you think about a standard forward flow typing, a function site's just like a basic block merge pointer region. A bunch of values come in to the parameters, they all get merged. You lose all precision because you've just merged them, just like a feed node. You run through the function with approximated parameters, you have a crappy answer at the output, and then you pass it out to all the callers. So if you have a common function like a map over collection, as soon as you pass in different collections and different mapping functions, everyone's approximated to hell and gone, you lose everything. Okay, that's the known flaw with forward flow typing. And this is what everyone with, you know, Java and C all fixed by adding in typing values and giving it up. Like generics just type erase and do casting. That's the other, you know, another version of that fail. So Hindly-Milner says, no, we'll not make the function body approximate the inputs, but instead we'll map the function's shape, if you will, what it imposes as a shape on its arguments, back to each individual call site separately. And that's where you do this fresh unify thing, where you make a fresh copy of basically the shape of the function body, and then you force each separate call site to match that shape, and then you get your precision back. So when I do this with forward flow typing, what it means is I am doing I'm talking about this lattice thing. I do a join, not a meet, but a join at each application site to lift the return from the function, which had been the approximated from the flow, to what Hindly-Milner says, no, you're actually sharp according to the Hindly-Milner mapping scheme there. So I get to lift types at call sites in forward flow typing, which is the whole point. But it means that every time I do a graph shape change, I have to preserve the level of quality that Hindly-Milner had given me for lifting types at every call site, because if I don't, then I lose the lifting from Hindly-Milner, and then that immediately makes my graph be not monotonic, and you fail monotonicity rules. So there was this funny interaction that direction, and the reverse happens as well, where I change the graph shape. I have to make sure that the Hindly-Milner style types go with the transform. Like every graph transformation I do preserves monotonicity, but I have to carry types along and monotonically force them. That's been the case for a long time. Now I'm also doing that for Hindly-Milner, where if I have a particular precision of graph shape, when I do a graph rewrite, I have to verify that every new node that comes back in has the same level of precision, or else I lose something at Hindly-Milner, which I might be able to rediscover, but while I have lost it, I will not also then have it for the monotonicity lifting later in the forward flow when the two sides inject on each other. So every small graph transformation, so every abstract interpretation where I rewrite the graph has a complicated thing to do with Hindly-Milner, where it preserves precision there and it preserves monotonicity. So that was a whole class of bugs that I had to go chase down and throw down asserts to validate that I was actually catching them all and finding them and stuff. So that was, you know, the last 2 weeks of like, oh, look at this thing I have to go take care of. Oh, there's another one. Here's another one. That being said, I think I've crossed the threshold sometime this last week, and about 3/4 of my ugly evil test cases are all running straight up, and the rest I'm sure I'm missing something stupid. Like today's stupidity was I had sharpened done a precision sharpening of a function call, which I'm doing for primitives. In this case, I did it to claim an argument parameter would never be null. So it was known not null as the precision sharpening. And then I failed to, somewhere, I haven't yet tracked that one down, I have failed to flow it correctly. And so someone is passing a null parameter to a function which cannot take a null, and quickly I prove false is true and die. So that's the current state of the world, but I think I know where it is and what it is, and it won't be too bad.
Math, I had a number of those proofs where 0 = 1.
Yes, exactly. Yeah. The compiler here, or at least mine, is just basically a giant theorem prover. So, you know, he's all happy to given conflicting facts, he's all happy to prove false is true. And then typically he then proves everyone is either the top value or all the bottom value, depending which way he hit it wrong first. If it goes to the bottom value, it's good because I declare that an error state. He stops making progress and eventually pukes out an error that's not terribly related because of bugs, but at least he pukes an error and has a program. If he goes to the top side of things, then typical answer, he declares the code all dead and throws it away, with the empty program. He gets to the end, says, I'm done now, and here's your program. It's the empty program. So it's not even returning at 0, it's just empty. Okay, that didn't help any.
Very fast, though.
Yes. Once he falls over that cliff, it cleans up quick. Yeah. One good dead thing leads to another, and pretty soon your program has been eaten up.
That doesn't sound that hard to detect, though.
Well, some of it's all legal, like all dead code falls into that camp. So it just looks like more dead code, and he's happily to throw your dead away. No, at the end, it's easy.
Is it worth changing the language to say all dead code is not legal?
Well, right, but I do that already. So I get to the end, it's all been dead, I've thrown it all away. Like incrementally, I throw things away all the time that are dead. That just happens. So I get to the end, I've thrown it all away. Then I take that result, which is the empty result, which it's top in the lattice value, and I compare it to my expected output. Well, my expected output is something clever related to the test, and it's not equal to top. And I say, oops, top is not equal to 1 or whatever I was looking for. And that's my hint that I had the empty collapse. And now when and where did it start collapsing? Like some dead is okay, so you can't just like stop at finding a piece of dead code, because like, you get dead code all the time. In particular, the common graph transformation is to make a new thing to replace the old thing, wire the new thing in, and then the old thing went dead, and it cleans up in the dead code. So I see dead code all the time. I don't have a threshold that says this is too much dead. You can't do that. So I don't find those till I'm like way late in the game. Yeah, you'd like to believe it'd be an easy hack. But if the user writes a program that says, if true, run entire program, if false, return 0, and that's the whole program, and it starts out with an if false, then the entire program's dead, and that's correct. So the obvious way you get those, by the way, is you use a command line argument that says -- usage. And it's if -- usage, print a string, and the entire program's dead. All right, somebody else's turn. Or ask what questions about what I'm doing, because I'm happy to still talk about this stuff because it helps me figure out what the hell I'm doing or doing wrong.
I was going to continue the conversation from last week on mixins, but I'm not sure if.
You can do that.
I'm not sure if I'm trying to remember who was asking the question.
Somebody asked me a question about the history of HotSpot, and I ranted, and then it was quiet, and you weren't there, or you weren't saying anything, so then I went on what I'm doing right now. But I don't care how we got here.
Yeah, but there was a really good question last week, and of course, anytime good questions come up, I have a hard time answering them. I don't know if you've ever experienced that, where it's all in your head, but it doesn't come out in English.
Oh, no, that happens to me all the time.
But
the question I had asked was for the poster child use case for all your mixin stuff.
Yeah.
So what I wanted to say, but couldn't figure out a good way to say, is it's about composition, right? Like the only difficult thing we have left in computer science, in my opinion, is composing things. Like we've pretty much figured out how to add things and subtract things and loop and return and call and whatnot.
Cache consistency and naming.
Yes,
well,
by one error. You're off by at least one because you missed off by one error.
Yeah, the only two hard problems in computer science are off by one errors. So, are you acquainted with the concept of there's a Philip Wadler came up with this term called the expression problem.
Yeah.
Does that ring a bell?
No, it does ring a bell, and I haven't looked at it in a while. I don't remember exactly what was going on, but I totally remember.
Give it 10 seconds and Matt will post a link. But basically, the expression problem, for sake of argument, is basically the summary of who's right, who's wrong between object orientation and functional programming. And
I'm busy trying to span both of them. That's the
So
reason here.
exactly, because what object orientation gives you is the ability to, so long and short. So the expression problem says, okay, I've got a library or a module, whatever you want to call it in your language, and I'm not going to change it. So it's already compiled, and you can't recompile it. It's given to you, right? It's a fixed asset, right? And now what I want you to do is add a new type that provides the functionality of the things in that library. And object-oriented people are like, yes, we can do this, right? We subclass this. So, I'm using C# or Java, and I say, class, my super duper, extends something out of that library, right? I don't have to change the library to do that. And I can implement that whole API, right? Whatever parts I want to override, I can go in and say, it has a foo, so I'm going to override foo, and it has a bar, I'm going to override bar, right? So it goes through one by one and fills in the blanks, right? And then Wadler says, hey, buddy, says, okay, different problem, right? I've got the same library, it's already prepackaged, already binary, can't change it. Now I want you to add a capability that the designer, so the first one was I want you to add a type that the library didn't think of. Second one is I want you to add a capability that they didn't think of, right? And so the functional programming guys are like, yes, we got this, right? Because we can just add a function and it deals with any number of types, right? So functional programming gets that access and they're happy. And then Phil Wadler asks the question, basically, and you can see that there's various pictures. If you look up expression problem, you'll see this kind of two-dimensional graph. And it's like, okay, so in one case I can add types, the other case I can add functions, right? But there's this overlapping thing. If I add types and functions, right, there's that part of the graph that's not covered, right? So how is it that I can take that compiled module, add new types, add new functions, and everything works? And it's actually solvable. I know this is going to be funny, but it's actually solvable in C++ because of multiple inheritance, right? Yes, I love that look, Cliff. Exactly. So, but it's about composition, right? In object orientation, with the typical object-oriented programming language that has, single inheritance, and that's pretty much it. We can add new types, inherit and override. And in functional programming, we can add new functions and so on. But what a mixin gives you is the ability, for sake of argument, because I'm describing it in single inheritance terms, gives you the ability to take a subclass and apply it to any number of superclasses. So, like in a Lego, if Lego blocks were built like object-oriented programming languages, each Lego block would only be allowed to sit on top of one Lego block. Like, you're like, well, I want to plug it onto this one. Nope, sorry, I can't do that, right? But a mixin says, well, anything that has those little round things sticking out the top, you can put me on top of. That's what a mixin does. It's a building block that isn't tightly bound to one and only one type, right? So instead of being bound to, it's more loosely bound to a type. It's bound by interface. So it's a subclass by interface, but it's a class, not an So a mixin is a class that declares what kind of thing it plugs into. And as such, it's they're trying to describe it. It's like having the benefits of multiple inheritance without the ugliness of C++. I guess that's my long and the short of it.
You were really good right up to the last part there.
I hope you're not a C++ fan.
I'm not, but we can do better than this.
Yeah. So I have a fair number of use cases, but the the benefit is that I can build a subclass without knowing what the superclass is. So in the same way that inheritance means you can write the superclass without knowing who's going to subclass you, a mixin is like the ability to write the subclass without knowing who the superclass is. And it's actually pretty freaking cool. So I can't imagine living without it, but until you experience it, it's hard to look back. So
the next question is, if it's like a class, then I can have something that's be declared of the mixin class. It happens to have a super, which I don't know statically. What properties do I get off the super? If I only know you as the mixin class, what properties do I get off the super, if any?
So keep in mind that I'm not a computer scientist. So I stayed at a Holiday Inn Express. So I don't really know what I'm talking about, but what we did when we designed mixins is we said, describe it by the plug, right? So for example, we'll say, mixin, I
want to have a thing I can throw into a hash table. So I want to have a hashable, and therefore it has to have a hash code.
Well, so exactly. So instead of saying hash, so let's say I have a mixin that applies to a map. So I would say mixin, my thing that gets added to a map I mix it into map, right? So what does it have that it can super to? Well, anything in map. Right? So
you declare.
I declare its super type by the type.
Okay, but it's plugged into individual subtypes of map. Like I have
So I could just say new. Let's say I make this mixin. We'll call it M. So I can say new at M hash map, new at M list map, new at M array map, right? Whatever.
Right. So the mixin M knows what a map knows. The object that's created is a hash map or a list map or an array map or whatever the hell it is. The map as a instance object, the mixin as an instance object knows the map interface. It's like an interface.
Right.
It's like knowing an object as you know it by the interface only. What's the difference between an interface now? That's what I'm missing.
Well,
interfaces don't require anything from their super. They only can.
Well, interfaces don't really have supers. Interfaces describe a surface area.
Yeah, right.
And they may provide default implementation. But, so for example, let's say I know reflection and I don't want to write a toString ever again. So I write, my reflection string outputter mixin. And what it does is it uses reflection, looks at all the properties, puts together the most beautiful string you've ever seen for any class in the universe. So now if I want to use it, I just say new, my mixin onto some class. So when I create that class, I subclass it with this super duper functionality. And I can do that to any class because every class is an object and has reflective ability, say Java or C# as an example, right? Obviously, it's language specific.
The thing that you got out is of type mixin.
No, the thing you got out is the type you created, which is that class plus the mixin on top of it. And that's why I talk about it as composition. So the ability to, what is composition in software? It's how we glue things together, right? And or glue things or stack them or, plug them together in the Lego sense or whatever. I mean, it's just how we put things together. And what we'd like to do, and this, I haven't fully thought out how to explain it in English, but there is this concept in software, so it's not original, I'm sure you've heard it before, that there should be exactly one best place for each piece of code, right? And every language I've ever used, and ours is no exception to this, of course, every language has a problem where you end up with a piece of code here and a piece of code here, and they're really, really similar, almost identical, maybe identical, right? And you're like, I wish there was some magic where I could just, have that one time, right? So what mixins do is it says I've got these 1,000 classes, and I have one piece of code I'd like to subclass or put on each one of those 1,000. And now I can do that and have that code in one place. So as a composition attribute, as a composition capability, it's incredibly useful.
I worry
Yeah.
that this sounds a little bit like there are two best places for this code. We need to make sure there's exactly one. Okay, here's the new method. Now there are 3 best places for this code.
So, mea culpa. I hear you. You know, if there were one obvious best way to do everything, I think we wouldn't be having this conversation, because someone would have solved it in the 60s and called it small talk.
Yeah, I think Julia folks do multi-dispatch.
I retch at the thought. Multiple dispatch is a broken idea.
Claim is it solves, I believe their claim is it solves the very problem you're talking about.
It does solve this problem in the ugliest possible way. So, and I know I was making fun of C++ earlier, but multiple dispatch is just...
I got a client who's in love with Julia, and boy, it's got some warts. I'm getting to learn Julia much more than I ever wanted to.
So, you know, I did spend some time looking at multiple dispatch in detail, and Julia to some extent, but it seems to be that the only problem it solves well is binary operators for a compiler. Okay, I want to implement add. Okay, int add int, that was easy. Double add double, that was easy. Okay, what about int add double? And I also want to solve double add int. And in Julia, that means
matrix addition plus a scalar.
So in Julia, you end up writing four functions.
Yeah.
Right, and then you route stuff around, and you know whatever. But it is the so multiple dispatch ends up. What's the stupid thing in SQL that you never want to do? Help me out, Cliff.
I don't know SQL. Holy crap!
So I select star from 2 tables and don't give it a where. What's that? A Cartesian product, right? So multiple dispatch is the Cartesian product of programming languages. So if you really want to hurt yourself, go multiple dispatch.
Yeah.
Come on, nobody else is talking. I'm giving opinions without any basis. So
well, you're very exciting with your opinions, which is always good. Very excited. No. This is I'm enjoying hearing this.
So Yorick has something.
I do this thing, so I get to learn something. Not just Cameron's excited about what he's doing, but mixins as a concept and why they exist. So I think you're doing great, dude.
Go Yorick.
Yeah, so mixins in Ruby are very common. They're one of the building blocks, but you know, Ruby being dynamically typed, I think you lose some of the value. Like you can't say, hey, this module, as Ruby calls them, requires these other ones. Like there's no way of saying that.
I love Ruby, by the way. It's freaking brilliant. It's like there are a lot of really good ideas there. I've never actually programmed in it, but it's everything I've read. It's like, this makes sense. Mats is the guy, right? Mats.
Yeah, and after 10 years, I have a slightly different opinion.
Exactly. Yeah, any language you've never programmed in always looks cool or stupid until you get into it. And then some of its good things are good, and some of its bad things are bad.
Like, don't get me wrong. Like, Ruby has basically paid my bills for like the last 8 years, and you know, it's a language great for many things. I think what they're kind of suffering from nowadays is a lack of clear vision. And so they are trying different things or putting in different things from different languages. And a lot of it is like experimental state. It's not really clear where it's going. Like as an example, it still has a global interpreter lock. And then as part of Ruby version 3, which came out, I think, a few months ago, they added a mechanism to achieve true parallelism through a system which they call reactors, I think, or rectors. And the closest equivalent is basically you spin up an entirely separate Ruby VM, and it does share the code. But then between these rectors, you use copying of data, which on the surface sounds
like
interesting.
Message passing, classic.
JavaScript workers.
Yeah.
It's kind of like sort of, you know, Erlang style processes where you use copying between them.
Yeah.
The thing is, a rector can be made up of different threads. And it's not like one vector equals one concurrent task. It's more like a sort of a sub VM, I guess, best way of saying it. And it's, it's one approach, but after 8 years, I think I at least am of the opinion, like, just start working on getting rid of the damn global interpreter lock. I know why they don't do it. Like, it will break a lot of C extensions and stuff, but you have to work towards that, I think.
Yeah, you got the Python problem. You got too many eggs you have to break to get yourself to where you can JIT code and run fast. And so, they're too afraid to break all the eggs, so they haven't. And so they're just like getting slower and slower and slower.
Yeah, so and they have this JIT where they generate C code, and the way they JIT is actually call GCC to compile the C code.
Yeah,
it's very like.
Is this Python?
Yeah, it's a bit bizarre.
No, Ruby.
That's a JIT.
Ruby has a JIT.
Ruby. Really? Okay. Calling GCC. Wow, that's even worse than calling LLVM.
They introduced it, I think, like a year ago. Still somewhat experimental as well. I believe the consensus so far is that it works, the typical benchmarks that people use for JITs, but everything else it actually makes slower. So Ruby on Rails, for example, the reason a lot of people use Ruby, I believe, is made considerably slower with it. Now, in their defense, Ruby
on Rails
has...
is kind of hard to JIT because there's a lot of dynamic dispatch because the whole thing is built on mixins.
Yeah, I was basically just going to say, like, there's so much meta programming in Ruby that not just compiling, but optimizing it in general is really difficult.
Yeah, and a lot of the dispatch in Rails is string-based as well, right? Because you get some string, and that tells you what the name of the thing is you should be calling. It's like value-driven function calls.
You can intercept messages, method calls, basically, and then say, oh, if it's this method, delegate it to here and things like that.
So you're passing messages as strings that intend to invoke methods somehow.
There are some optimizations for it here and there. And sorry.
Yeah.
I believe in many cases it is actually quite a bit faster than Python.
Yeah.
I think part of it because Python uses reference counting in about the worst way you can do it.
Yeah, well, fine. I looked hard at like faster Python versions and how to make them go faster and PyPy and stuff. And there's a bunch of things that can be done, and some of the alternative things do much better. But I don't know if the core Python implementation.
No, so Python kind of dug themselves a hole where they, as part of the language spec, I believe, they guarantee deterministic destructors.
Yeah, right.
And that immediately means you can't do things like deferred counting or coalescing or whatever.
Right.
But overall, Ruby is a fantastic language for many reasons. But after 8 years, I'm personally of the opinion that once you have a big project, lots of developers working on it, exact numbers doesn't really matter. But let's say my employee GitLab, for example, the product I know is like 100,000 lines of code, and it's like 400 developers or so working on it. Not all backend, but a sizable portion. The dynamically typed nature combined with the extreme level of meta programming in Ruby means that you can take any file and you can look at it for hours and still don't know what it's doing. And you basically have to rely on people naming variables according to their types. So if you have a user, it's typically called the variable user, but it might not be. So you get variables like user project. You're like, okay, what are we dealing with? Right.
Hence Hungarian notation, right?
Yeah, well, yeah. So this is where you get in sort of static versus dynamic typing
But
debate.
Strong typing is for weak minds, which after you get 400 people, 100,000 lines of code, that's pretty much everybody.
No, I can't go back to a non-static language for any multi-user project.
Yeah, I think I would argue, or I suspect a lot of people who are in favor of dynamic typing are either for very specific purposes. So it's great for live coding, for example.
Live coding, yeah, exactly. Yeah.
It's great for prototyping. It's great for programs where there's only a couple of people working on it, and you can sort of keep everything in your head. Well, I would say 5 or 10, something like that.
Oh, 5! Wow. I'd have drawn the line at 2.
2, maybe.
Cameras is one.
And, obviously it depends on what you work on, right? Like if you build a, like, I don't know, a content management system, probably everything is strings anyway, so it's not going to make a huge difference. Also depends, of course, on what the software does, right? Like if it's a command line utility, if it's a banking program. But so
well, the banks
part of the issue of Ruby with its meta programming is also that there aren't really that many good analysis tools for it.
Right.
The closest we have now is called Sorbet, made by a bunch of people at Stripe, and it's static analysis. Woohoo! But the way it really has to do its work is it has these sort of separate definition files, kind of like C headers, where it says, this type has these methods, blah, blah, blah. And so you essentially end up having to annotate all your code as a statically typed language, except for whatever reason they put it in a separate file, which has been quite widely criticized. But the most annoying thing for me there is that this isn't the first static analysis tool for Ruby. There have been dozens over the last 10, 20 years. I wrote one myself, read a bunch of papers on them. And what I remember, the universal conclusion was that this only works if you put the types in the code and if you basically make it as frictionless as possible.
Yes, yes.
And that's what
JavaScript and TypeScript or FlowScript or whatever.
Right.
Yeah. It's not frictionless, people won't bother.
And the meta programming basically makes it impossible to have it 100% accurate. Like unless a developer annotates everything, even the meta programmed stuff.
Right, that's tough.
I found this, I wrote a static analysis tool for it back in, I think 2013. And somewhere around 2015, I basically gave up. And it was, the code was kind of weird. It was the first time basically doing anything compiler related, but it worked. And it was capable of handling, reasonably simple Ruby programs. But it also had to use these definition files to, for example, handle the standard library. One thing I did there was I didn't come up with my own syntax. I basically had it parse these documentation tags that a lot of Ruby projects were already using.
Yeah.
So they're kind of like the Java doc comments.
Yeah, right. Yeah.
But yeah, the moment you let that loose on Rails, for example, like your accuracy went from like, let's say 90% to like 1%. Because everything is dynamically generated, like methods are generated based on database schemas on the fly, all sorts of things.
Yeah, what I've found is that the typeless, if you will, the dynamically typed languages are particularly useful when you have an excellent, large, stable, statically typed system that you want to do something with, right? So I need to add something that pushes that button or, changes that label, right? It's nice to have a dynamically typed language where I can write 2 lines of code instead of a class. But building a system, and I have some experience in typeless languages, having, where I met the co-founder here was actually working in a company where we built a database in a typeless system.
Oh, you built the database itself in a typeless system?
Yeah. So I have some horror stories.
I mean,
I'd say that would sound self-inflicted, though.
Well,
SQLite is basically a database with a typeless system because it escaped from Tickle.
Ooh, SQLite. Yeah, okay. I don't know anything about SQLite other than has SQL the name, so I'm staying away. I'm working with this client doing this SQL replacement language with, expressive relational programming, and they're using Julia. At least that types some kind. They're dying left and right because Julia's type inference gives up the ghost silently and flips to dynamic dispatch with a 10-fold reduction in speed because it can't be JITted. So, 100 times every time I go looking at what performances, there's some place where they have failed silently. And I would much rather Julia just like barfed and died. It's a typing error, not a, we'll run 10 times slower error. Yeah.
So one of the comments in the chat was from Yorick. He said mixins can carry state,
Yeah.
which is that's a good point.
Yeah.
So some languages don't let their mixin. So there are two different words that are used sometimes confusingly. So traits and mixins sometimes get used interchangeably.
Yeah.
But there are languages that have stateless mixins. And we originally, when we designed Ecstasy, included such a thing. We called it a trait. And then there's other languages that do stateful mixins, and that's what we ended up with. We dropped the stateless thing just as a way of reducing surface area, cognitive load.
So if I have
Yeah.
a thing, maybe I answered
Go
my own
ahead.
question already. Never mind. If a thing typed as a mixin, I also include the super it was mixed in as its type. That's known as part of its type, which gets me around to the question of performance, which is dispatch, which tells me something about dynamic dispatch. It's fine. Okay.
Yeah, I think the confusing thing here is I believe TypeScript, they have interfaces. However, as far as I remember, they actually are mixins because you can specify this interface requires that whatever implements this has this field, which is
Right.
mixins. And then you have Swift, which has traits, I believe, but they call it protocols.
Yeah, the naming
There's
thing.
some languages where they call it traits, but it's actually interfaces. Like
I've seen those.
it's like
Okay.
ideally we just use interface for everything and slap it all together, but
Yeah, no, you have
Right.
to.
So there are three problems in computer science, I guess.
Yes.
So off by one error is in naming things. Yeah.
Yeah. And don't forget invalidating caches. It's fine. Yeah, that just means that when we talk about mixin, interface, or trait, any one of them, you have to clarify because each one of them can be used in the other's context by different people for different times. It's all fine.
Matt, I think, made a comment about visitor pattern. So visitor pattern is actually one of the kind of known solutions for the expression problem that we were talking about earlier. So in an OO language, typically you flip that access by using the visitor pattern. If you go back to the earlier conversation, so it allows you to add functions to arbitrary types by externalizing the functions into a visitor, if that makes sense.
Yeah.
I'm not sure, Matt, if that's what you're referring to.
I'll have to think about this more. I'm not there yet, but I'm hoping to get where you're at, Cameron, sometime the next year.
Yeah, I think the two-string example is a pretty good one because I think that's one you could probably visualize in Java as the ability to write a single two-string and apply it to any class using reflection.
I do much debug development work with custom two-string printers in enabling whatever they're designed to allow me to look at the string representation in the debugger where it dumps internal state and prettifies it, but not all state. And there are hard requirements that it shall not use like baked in self-improving caches, or else the act of enabling the debugger will cause a two-string, which will cause a thing to step forward his caching, which will change its behavior, which will hide the bug.
Yep.
So I have very complicated and subtle two-strings all throughout all my code. Oh, the other one, of course, is that string concatenation with plus is kind of a pain in the butt. And performance, when I'm building big strings, you need a string builder, but string builder is like 18 characters. And of course, you know me, it's string builder. So I have a string builder wrapper. I have all two strings forward to a stir function, which takes an SB for string builder, which wraps all the right things and has one character prints and appends and all those kind of things. It has a few other things to make collection printing convenient. You can do join like business and whatever fine things.
Right.
I actually can't do joins typically. I have to do a for loop where I have filtering. So then I need a way to handle the last extra comma that came in the collection to get rid of, so I can put my closing curly and shit like that. I'm ranting now. But two strings all over my life.
Yeah, I tell people that the there are two things I've never regretted in software. One is investing a huge amount of time in making each of my types be able to represent itself in a string. And the other is writing unit tests. And in both cases, I hate doing it, but it has always paid for itself many times over. So
there you go. I'm very much in the same boat. Like the first thing I do is I write the structure of the new thing I'm writing. And the second thing is I throw a toString and then I populate functions I would like it to have that all say unimplemented, and and then I start trying to plug it in and use it and solve my unimplementeds. But toString comes hard on the heels of what structure, what state you have. You have a toString right behind you. Yep.
Although the one trap there I warn people of is the toString for serializing this and sending it across the wire is very different than the toString for debugging.
Right. But my toString is for use in the debugger, and it does not carry or display all the state that is present. It does what I want to help me understand the.
So Aaron, when you said that, do you come from Smalltalk or something? Because that was the Smalltalk model, wasn't it?
Oh, it's almost the Java model.
Well, toString as the serialization representation was small because you had toString and fromString or something like that.
Yeah, it could be.
Yeah, mostly I ran across that with Python and sort of Django land stuff in particular that wants to be able to toString and fromString various objects. But that's not what you want to see when you're just like, I need a printf here so that I can see what's going on.
Right.
You print the object and you get this total serialization of it that is not meant for humans.
Right. No, if I'm looking for serialization behaviors, I write a separate thing for serializer, because the debuggers only hook toString unless you screw around mightily with them. So you hook toString for debugging.
Yeah, I would argue the sole purpose of toString is for debugging. Like realistically, I'm serious. What else would you do with it, right? This is not going to be something that's like presented to the end user of the application.
The stock Java, whatever advice is your toString is supposed to be reversible, and it's your serializer, deserializer start. And this is like completely ludicrous, but I see this all over the place.
I've never seen that.
Okay, fine. I have. And it just makes no sense to me. It's for debugging, yes.
Maybe integer.
I would go as far as saying like your objects shouldn't have a toString method. Numbers are an exception because there are a lot of cases where you take a number and you want to squash it into some existing string, like an email.
I like that idea. The only thing that should have text is numbers.
I kind of violate that rule of my own language because my array does have toString.
You're talking about a built-in toString.
No, so they are all custom. You have to implement them yourself. In my case,
right.
And anything done with any sort of reflection is done through mirrors. So the objects themselves, they don't expose a toString or a debug method or anything like that.
Okay, so the reason I do that is I typically have multiple layers of semantic meaning I'm trying to debug through. One of them is I have a lot of places where I do like target union find, for instance, which causes essentially long chains of things to be rolled up for efficiency purposes. And so everyone's got an adapter function or an accessor which does the roll up behind your back, except toString, which if it does the roll up, it hides from you the bug where you failed to have a roll up in the right places that you should have. So you cannot have a toString, but the toString wants to give me the semantic meaning of the effect of the roll up. So the toString walks the target union find list to the end to get the final value, but he then does not do the roll up, which is what the normal accessor does. So I lose the asymptotic good bounds and I lose the underlying internal shape change, but the semantic meaning is at the level of what I find at the end of the target union find chain. And that kind of behavior happens all over the place in the code. So not just target union find, but many similar kinds of behaviors. I have a semantic meaning, which is typically done through a very low level mindless successor, which does something algorithmic, which leads to bugs where you have failed to do the right thing with that roll up. Then therefore the toString cannot change the shape of the underlying structure, but has to be the semantic meaning, which has a complicated effort to get to the far side of things. That,
Yeah. I got lost there.
all right. It's not, you know what target union find is, right?
No.
Oh, you don't? Oh, fine. Oh, this is a stupid algorithm hack. You probably actually know it and don't know it. It's been around forever today. This is, I want to build I want to discover a set of things that are similar somehow and lazily on the fly. And I don't know to begin with that two things belong in the same set. But I discover it as I visit them somehow and ask a question that says, yes, you belong in the same set. Now efficiently build the set representation. And the can be used in many places here. Pointers, sets to analysis. There's a lot of places where this shows up. So the question of how to make an efficient representation is typically I make a set object, I start throwing them in, but then have a lot of set objects, and everyone who's in the set has to be mapped back and forth to and from the set. So Tarjan, mathematician from 40 years ago, said, here's this cool hack. So everyone just has a forwarding pointer and somebody's at the head of the forwarding pointer. That's your set representation. One of your instances in the set becomes the leader or the canonical example. And everyone else just points to the next guy in the line until they get to the head. And then the head says, no one's after me, so I am the head. That's why I'm the head. So if I want to take a set, a member of this set and a member of this set and discover they belong in the same set, but they have two parties of sets they belong to, I need to union two sets as I go. So all I do is I take the one guy and I point him to anybody in this set who then would follow the chain up to the root. So this would make you long chains of guys who point to each other. And if you visit things poorly, and algorithms do this all the time, you get a bad spline effect where the leader is at the long chain of point up hills to the last guy, and he's your leader. And other people have different chains, and many chains are short, but you get these bad chains. Okay. The asymptotic good behavior comes is if I need to point at the leader, but I'm pointing at somebody who points to somebody to the leader, then I walk the chain once to get to the leader. Then I go walk the chain a second time. It's all hot in my cache, and I make everyone point straight to the leader. Okay, having done that hack, what's the asymptotic running time after I make a complete linear pass over all my things and I've asked the question every which way? Stupidly, the answer is it's no worse than inverse Ackermann's function, which is essentially log n. So it's basically linear for all intents and purposes. So essentially, it's a constant time operation to walk the chain twice. Because you're walking it twice, the chains never get very long. They get inverse Ackermann's times long. Like every once in a blue moon, you get 2 instead of 1. Okay. If you fail to walk the chain and you say, this is the guy I'm looking for, but no, you want the leader, because you're saying, are these two sets equal? Well, I'll go to their leaders, and if the same leader, they're equal or not. If you fail to walk the chain, you're buggy. So you have to walk the chain for every semantic action you take. But you don't want the debugger to walk the chain because he will clean up your bugs behind your back. So the debugger toString cannot walk the chain, cannot collapse the chain. He walks the chain to get to the semantic owner, but he doesn't collapse the chain. So having long, go look target union find. I'll throw it in the chat here. It's an entirely useful algorithm for many things to do with compilers, but all kinds of other operations when you're just trying to discover people are this thing is like that thing and that thing is like this guy. So he's also like this other guy because it's transitive. And I don't know what that relationship is when I start. I make one pass and I now know the relationship. And asymptotically, it was a good runtime.
It almost reminds me of a compiler trying to check for aliveness.
I had this handed out to me.
Go find the entire tree.
Sorry, go ahead.
It reminds me a little bit of the way compiler would walk the object tree to try and find if everything's live.
Liveness analysis is different because liveness analysis doesn't collapse after the fact. Liveness analysis is you have to walk and you're just propagating facts. So that's what somebody said. You can do this with alias sets and points to sets and bit vectors and stuff. I have a SSA form, so I don't have to have a bit vector, but I do a walk. The walk propagates. So it's a graph algorithm. I'm drowning in graph algorithms. Is this the right link? It's got to be. You find the word Tarjan in here. Yeah, there you go. Robert Tarjan was first to prove the good runtime. Yeah. Online
we had
discovery of
we had a
sets.
race condition there because Matt beat you to it.
Oh, probably. Yeah, yeah. There you go. Okay, I'm yakking. Matt's like typing. Thank you, Matt. All I'm saying is toString. I have a lot of things where the standard accessor to get at something does a semantically preserving optimization, but does an optimization under the hood in order to get asymptotically better running time. But I can't have toString do that. So my toString cannot use the standard accessor in many cases. It has to have a custom one-off accessor.
Right, but so that in theory you can do that with mirrors as well. Like you can have different mirrors for different objects or for the same object.
Yeah, I don't know what you mean by mirrors, but anyone who takes the contents of these data structures and dumps them out doesn't help me in a toString. I need the semantically intelligent version.
Well, so mirror is basically a separate object. So you give it an object X, your mirror Y knows how to, for example, reflect on that X. So it knows how to perhaps print it or how to list the field names that it has. Generally, all the reflection that, for example, in Java, also in Ruby, just gets stuffed in the object itself. You take that, put it in a separate object, and that mirror basically just stores that object. So as an example, instead of doing something like foo.toString, you would say something, give me the mirror of foo and then call toString on that. And it will then print the toString for this foo thing.
Yeah, well, where am I? Sorry, I'm missing yet. Where do I win here?
It's largely so that the reflection logic can be completely decoupled from the object itself.
Right.
Which means, for example, you can disable it. You can compile your code without reflection support.
Wouldn't use reflection to go print an object, so I don't know.
I mean, it depends. If it's for debugging purposes, I think.
Exactly, that's what I'm saying. It's for debugging purposes, and it needs to be a smart print.
Right, but there's nothing stopping you from doing that, right? This, like, you can have some generic mirror that knows how to print any object in sort of a dumb way.
Yeah, that's a different thing, and I would claim Java did not do that well.
Right, but so as an example, in my language, there is a generic object mirror which prints objects in a generic way.
Yeah, fine.
But then, for example, the set type has its own mirror, so you can print it a little bit differently, similar, array, map, etc.
That is, if I ask for the toString for a class, the behavior you're promoting is I want to get something called a mirror and then toString it, and there's a common shared mirror for most things, and then I have custom one-off mirrors.
Yeah.
Whereas if I had a toString method that had a common shared base at the object class that used reflection to go print everything, wouldn't that give me the same behavior without the mirror?
It gives you the same result, but the means to get there are different. So in your case, you rely on objects having a sort of default behavior that you can't opt out of.
Well, you can override it to say
right, but the base method is always there.
The base method is always there. Yeah.
And it's not necessarily worse or better. I think it's just different means.
Okay.
So as an example, in my case, I don't have inheritance, and it was actually reflection that was making it difficult to get rid of that also in the sort of VM internals. Because what happened in my case, all objects had a method called mirror, which would obtain the mirror for that object. And I had it such that this was available by default, and it was achieved because at the VM level, there was inheritance. So I defined this mirror method on the top type, basically.
Right.
Top type. But that meant that even if inheritance wasn't exposed, as in like you couldn't define a class that inherits from something, it was still present. And I wanted to get rid of that for a number of different reasons. This mirror approach essentially lets you do that. Not in isolation, it helped. The combination I had to use was basically mirrors for all the reflection logic. And then I had a separate mirror function unrelated to any object. And it used pattern matching to determine which mirror to use. So you give it an object, can be anything, and it says, hey, if this object implements the mirrored trait, which provides the mirror method, then we use that. That way an object can specify its own mirrors if it so desires. Else we check, hey, are we dealing with a string, an integer, blah, blah, blah. The end idea being that if you don't do mirroring, all of that code isn't even present in your program, which also made bootstrapping easier because printing objects requires quite a bit of functionality to be present.
Yeah.
And
The
it's
hardest
created this
program
sort of,
a compiler writer ever writes, the hardest program a compiler ever runs is Hello World.
right. And this basically meant that even if your program wasn't depending on reflection, because it's sort of available by default, all of this code was imported by default.
Yeah.
And it took surprisingly a lot of effort to get rid of that. But so the result is now you define an object. It has the methods you define. It's not polluted with all these extra get class, get attribute, whatever methods, until you specifically say, hey, I want that.
Like,
So I used to work with a guy that had a saying, which is you could replace any if with another layer of indirection, or alternatively with another layer of inheritance. So Yorick, what you did is you replaced a layer of inheritance with an if.
Effectively, sort of yes. But for me, what it essentially comes down to, and I'll link to the paper in a second, is that you can opt out of it, and that the behavior specifically is opt-in. Right? So in Java, Ruby, Python, your reflection is there, even if you don't need it. Most of the time, that's fine. But there are some cases where you perhaps have an object and you don't want it to have all these extra methods. A classic case that I had to deal with recently is when you have a templating language, they typically have some sort of context object that they can pull their data from to display in the template. And sometimes you might want to extend that so that users can also call functions to do loops, for example. But what you don't want them to be able to do is call arbitrary methods that just happen to be defined on that object. And there are surprisingly many templating languages that do not deal with that properly.
Like Java would solve this with like an interface. You hand out the interface and it hides all other methods.
Right, but so the thing there is, as long as it's defined on the context object, there's probably some way people can get access to
reflection. You do reflection on the reference and you have everything.
So as a silly example there, there's a templating language called Mustache. A very limited templating language is advertised as being basically safe to use by users. It's logicless. The Ruby implementation, however, is not. Specifically, they use a particular object as a context, and the way the templating system works, you can call arbitrary methods on that. So the case to remember is if you print a variable, essentially what it does, it says, hey, does that context object respond to that message? If so, then yes, and we print the result of that. Now, by default in Ruby, the object's parent class they use doesn't have that many methods, and in particular doesn't have any harmful ones. But then you load in Rails, and suddenly now it has an asJSON method, for example. And when you call that, because of whatever it does, it ends up blowing up the stack. And so I was looking into this as a potential templating language to expose to users. And I found that out. I was like, oh, we're not going to use that. Like, we're not going to give users the ability to blow up the stack and, call arbitrary methods, basically. And in a case like that, for example, it might be nice to say, hey, I have an object. I don't want it to have any methods. At least in Ruby, this is quite common, so much that there's a general term for it called a blank slate. And there's some libraries that actually provide an object like that. And they literally have to define a class, extend the top type, which is basic object in Ruby, not object, and then explicitly undefine a bunch of methods. But it can't undefine all of them. I think if you undefine underscore, send, underscore, I think it was, all method dispatch for that object will break. And so it's this very fragile system because it's opt-in by default, and there's no way to opt out, basically.
Java reflection doesn't have anything to do with the object being reflected on. There's no method tied to it. You go to the reflection classes. If you have access to reflection classes, you can do anything the hell you want.
Right, but you can still ask any particular object, I think, directly, like, hey, give me the name of your fields, for example, as far as I remember.
No, you can do get class.
Right.
As soon as you do get class, you can say, give me the fields. Yeah, totally.
In the purest form, I think, of mirrors, even that isn't possible. Like, there's no get class. There's always this mirror, however you obtain that. And
yeah, it goes to the security model or the privacy model of Java.
Yeah, and there's some
in general.
In the original paper, they let me see if I found the right one.
Want to have some amount of access or reflection or self-awareness behavior for somebody who's making the object in the first place, but he wants to hand it off to somebody else, cross some security line where the person on the other side cannot do anything with that object outside of a list of known goodnesses.
Right. Yeah, and so one of the, I think the original paper they mentioned, one of the abilities is that you can reflect on remote objects because you're not tied in directly to the object. I haven't actually seen a use case for that. It strikes me more as something like, oh, it could be useful, but nobody ever in their right mind would do it. There's a lot of cases like that in programming. But for me, it's just much more about, hey, this is stuff most people probably wouldn't want to interact with directly unless they're in a debugger. So let's just make that optional so that it's not there. And that comes to, like, I hate systems where you have to opt out, whether it's cookies, methods, or newsletters. Like, no, if I don't tell you to do it, just don't do it, basically.
Yeah. It's Firefox mode of I wipe all cookies every time I close a page. Works great. It's fine. Yeah, I don't know. I've been running my head around the whole how do you hand off something to somebody that says, like, an object that they can do what they want with up to some limits. A caller gets to specify the callee what he is allowed to go fiddle with. Where's your security model breakpoint? In particular, if I hand you a thing, you're allowed to reflect on it for all those fields that I told you that you can see, and everything else you can't go reflect on. If you ask for those fields, I won't admit they exist, and all that kind of stuff has to.
This is where we chose to differentiate between type and class. So, which makes it really handy because you can certainly reflect against either, but when you're injecting something into a container, it's the injection type that you can see. So you ask, there's an object. Our object doesn't have get class. So you have a reference, though. In the reference, you can say, are you from a class? And if it's injected, the answer is no.
Are you even from a class?
Right, because you can't.
Yeah.
Because basically what you're dealing with conceptually, you're dealing with a proxy from a.
Right.
Yeah.
I get it. You want that line perfect or whatever so that the client cannot detect the server's implementation, so the server can change implementations, including being across the wire versus local.
And not just that, even if you know what its implementation is. So, I mean, this is one of the goals that we had is even if you had the source code, you have all the source code. So you could even stick the source code into your container and say, okay, I know that reference that I was given is one of these things. So I'm going to cast it. I'm going to try to force it into that mold, right?
Right. Yeah.
And it still wouldn't work.
That's correct. That should fail.
because
I mean, that's what Java was trying to do with class loaders. It's fine.
right.
The other side of the class loader game is that the object you got was of a different, basically a different class.
Yes, exactly.
Yeah.
So you're passing in the same instance, but just sort of as a different class.
You imagine
You like
that,
pass this thing as interface, and if you try to call anything that's not on the interface, it's going to pretend that doesn't exist.
Effectively, that is exactly what happens. Yes.
but it's perfect. And the reason you passed the original object through is you didn't want to pay the cost of copying it, or you didn't want to make it obvious that you had to copy it in order to get your thing. If you're going over the wire, you copied it already. But if you're trying to be efficient and you're all doing local things, you don't want to copy it. You just want to, it's message passing. Here's the message. It's the pointer to the message buffer. I just hand the pointer across the wire to you. Okay, but on the other side, you don't get to know anything about it other than what I told you the type of the message was.
Right. And this is where that fat pointer concept gets handy as well, right? Because it's like, you could think of it, remember, so it's like you have kind of two parts, right? You have the type. So a reference is composed of two things, right? Think of it like a pointer to a vtable and a pointer to a struct, right? So call the pointer to the vtable the type, and the pointer to the struct is the identity, right? So you have these two things, right? Now all I have to do, if I want to strip the ability for you to call, this method and this method, is I take this type off, I glue another one on, and I pass you that pointer. So now
But you better stop the receiver from casting it back.
Yeah, the receiver can't cast it back. That's what he's
yes,
saying.
we don't have the same concept of cast as would be present in, say, Java or C. It's a different concept. So it's a type assertion is what a cast is.
Yeah.
And since it's a type assertion, you say, are you this type? It says no. You say, well, there, you're done.
So you can narrow, but you can never widen.
So when something's injected, you cannot widen it beyond the injection type, correct? Within your container, you can do whatever you want. Within your own container, you create something, you can go whack on its private fields. You can in security, it's the age-old question of who are you defending from, right? Most programmers, when they're learning how to program, they write a lot of code to defend from themselves, right? But security is not about defending from yourself. It's defending from anyone else, right? So whatever you create within your own container, that's your own mess. You can whack away at it all you want.
Yeah, I understand your perspective, but even writing, code for myself just to do random things, I write private and final everywhere that makes sense to protect from myself. And I came to realize a while back that in Java 11, and I forget whether it came earlier, a nest can access private things of anywhere. And so when I thought I was trying to protect myself, I wasn't really. So that was a disappointment.
Right. So Java has a security manager that actually can deal with that all correctly, but nobody uses it because the performance hits too big. It's only like 20-25%, but I mean it's still a big deal.
Well, I'm not talking about that sort of thing. Like I'll write a nested class, and the interface to that nested class I lock down, but now you can't, because everything, even if it's private, is still accessible to the other members of the nest.
That's correct, because the compiler generates additional methods. So when you think you're calling,
no, it doesn't generate anything. Not anymore.
It generates. Oh, it doesn't.
No.
Yeah, they changed the accessibility.
The VM access rules.
Yeah, and we actually had bugs in our analysis for effectively final fields because of that, because we thought that, well, if the field is private, nobody other than this class can access it. But in Java 11, they introduced the concept of nests, and classes within the same nests can access private fields of each other.
So Keith, what we do is we have private, protected, public, etc. But we allow, if you create something within your container, you create an instance of something within your container. We allow you to go around that protection. But if there's something passed into your container, there's nothing you can do with it.
Yeah, that makes sense.
And by the way, that solves the serialization problem that Java is crippled by if you Brian Getz talks about this a lot, but serialization is like magic because it doesn't follow any rules in Java.
Yeah.
And it's a huge security hole, potential security hole. And because I can take something, serialize it, change the serialized form, deserialize it, and poof, it's like I went around any potential security.
The deserializer has to reapply all it takes a pile of bytes from God knows where. It has to reapply all security rules.
That's right. So, but what's handy is basically we have, for any given object, we have 4 built-in representations. We have a public representation, a protected representation, a private representation. And those are like 3 different, remember we had the identity and the type. Those are like 3 different types glued onto the same identity, right? But we also have a struct representation, which like completely non-virtual, basically it is if you will, the C struct view of the data. So if I create an object, I can just say, hey, give me the struct for that. And that is the thing you would serialize, potentially. I mean, obviously you can serialize any way you want to, but if you were doing a Java style serialization, that's what you would use to serialize.
Can I ask that on a thing that you've injected?
No, of course not.
Okay, fine. Yeah, fine. Yeah.
So if you're putting all the type,
yeah, but you're putting memory layout, basically. Like the garbage collector needs that type. The compiler needs that type. So you might as well have it as well.
Yeah, sorry, I missed your question, Aaron.
Yeah.
If you have an array of the type, but you're storing the class in the fat pointer, if I have my array of pets and some of them are cats and some of them are dogs, do I now need to have array of pointers to pets? Or like, how do I do the tag?
It actually works both ways. So that's a decision made by the runtime. It's one of the design goals that we had, that we wanted to be able to inflate an array to hold arrays of structures, because there's a whole bunch of decisions that go together. So each of these decisions looks like it sits in a vacuum, but they're all interlocked very tightly. So to do what you're describing, one of the things we define explicitly as a first-class concept is immutability. Because once you have immutability, you have the ability to copy yet retain the same identity. So for example, if my pets are all immutable, then I can inflate the array to actually hold the structures. Or I could have the array just hold pointers. So I get either choice. Now, does it hold pointers or does it hold structures? You can actually, through reflection, you can actually ask that question dynamically at runtime on an array by array, at any object. You can infer that information. But it's it goes back to what I said to Cliff before. Like, after you've used HotSpot, after you've seen what it does, you can't go back, right? The only person who should be making any of these decisions is the software running at runtime, because it's the only one that knows what's better. And if it's not true, it just means it's not done yet.
I'll say that Julia allows you to make that decision, and they frequently screw it up, or they have some weird things. I've fallen over bad choices made here repeatedly by the Julia compiler, by the users of the Julia system who are demanding it left or right. I don't know. So yeah, it can certainly be wrongly done, that's for sure. And I think allowing a user to say, I want it inflated or not, you has to be careful.
Yeah, I have no desire to complicate things with that.
And if you're immutable, you do actually get the choice. If you're mutable, if your pets are mutable, obviously you can't do that, but that's a decision. So I have a different question that actually, I was trying to remember. So when you inject an array of a collection of widgets, and I want all my widgets to be like brain sliced to lose their deserializer, what do you do with that? You walk the array and smack the pointer for every one of them?
Yes.
Okay. So the act of copying an array or a collection in general of type smart.
It's even worse. It's even worse.
Dumb.
Let's say I have a mutable array.
Yeah.
And I want to inject a mutable array.
Yeah.
it actually will freeze. It'll actually freeze the array, which chances are will clone the things being passed through.
Oh, so this is a different one. So this says at the, ooh, so the caller of a service can't witfully, intelligently say, here is a mutable array, and I promise, for instance, I promise not to touch it for the duration of this call. And then you can feel free to mutate it, and then I'll understand it's mutated when it came back. Because there's also like the parallel version where, please, Mr. Collection, only alter every odd numbered one, and I'm going to alter the even numbered ones in parallel and shit like that.
We don't have, yeah, I mean, so you're kind of in Rust territory now with the borrower and whatnot. So we don't do anything with that respect, with one exception, which is IO buffers.
What do you do? Yeah.
Do you really want to know?
Well, up to a point. I mean,
so we wrote the IO buffers as if they were terribly, terribly inefficient in Ecstasy. And then, but the design supports the contracts that we want so that the runtime can say, I'm not using that frickin' code. So because it's about, optimization is about contracts, right? It's all contracts, right? And you have to be like a frickin' lawyer.
But okay, fine.
You have to be a lawyer, right, when you design a contract, because whatever you don't cross out in the contract,
yeah, right,
you're stuck with it.
Right.
Like every line in the contract is a reason why you can't optimize.
Yeah.
So the ideal contract is you go through and cross everything out, right? Because now you can optimize it any way you want, right? So go back to our earlier discussions with global interpreter lock and blah, blah, blah.
All right, now get back to IO buffers here.
So the way we do IO buffers, what we want, so I describe it in terms of a, you go to the airport. So you go to a busy airport in Europe, and they have, so they have a security line, and they basically bulk feed through the machine. So there are like 6 spots on the conveyor belt that 6 different people walk up to. They grab a bucket from underneath, they put it on top, they start loading it, it goes, right? They grab the next bucket. And ideally,
it's way more efficient than the American system, that's for sure.
Ideally, you're traveling with someone, they go to the other end, and you use a total of 2 buckets because you're loading one and they're unloading one. So you only need 2 buckets per.
Right.
In theory, you only need 2 buckets per socket.
Small finite count, and you're recycling your buckets.
Right. Yeah. But the latency of the machine itself says, oh, no, I'm going to take some time to x-ray this, right? So now I need 3 buckets. Maybe I need 4 buckets because I always want someone unloading.
So yeah. So you need some buckets, fine. Right. A ring buffer, collection of buckets, your side.
But every time I add a buffer, every time I add a new bucket, I'm killing my cache, and I'm killing my I'm using way too much memory bandwidth, right? Because I have to flush my buffer. So anyway, so the ideal is that you want to limit memory, you want to limit bus usage, and you want to maximize cache utilization, right? But at the same time, there will be times you want to add more buckets to avoid unavoidable
delay, right? As the network packets are slowly dribbling in a byte at a time because I'm on some badass Wi-Fi in some evil European cafe. Fine.
Right. And I never really understood the Nagel's algorithm until I was designing buffer management. And suddenly it's like, that's
worth understanding. Yes.
Totally off topic, but same area. So anyway, so the way we implement it is that the every time you ask the buffer for a write, you ask the thing that represents a bucket. You ask it for a write buffer, and that's where you're filling the bucket.
Yeah.
And then you ask that for a read buffer.
Yeah.
And as soon as you ask it for the read buffer, any call to the write buffer fails. So the write buffer is invalidated when you ask for the read buffer. And then the read buffer recycles, and as soon as it's recycled, any call to the read buffer fails. So there's underneath this, there's a read-write array, and the write buffer is just a veneer on it. And then when I'm done with the write buffer, I flip it using NIO terms. I flip it to a read buffer, same array, different object.
Right.
So I'm allocating an object each time I go to write or each time I go to read, which is hugely wasteful. Plus it's a veneer, which is hugely so it's terribly, terribly inefficient, but it allows us to write the contract in super strict terms. So now the runtime can say, oh, forget all that. Like I'll give you a reference. That's your write buffer. right? And as soon as you call this method that says I'm done, I need a read buffer, poof, I have a new reference, and that's the one that gets passed over.
And it's
And
the
the old
same reference
references.
as the write buffer. You're just declaring it a read buffer.
Yes.
But you have to have somewhere when you're finished writing, you have a flush going on, I assume. And then there's some semantic meaning involved. You go off to your service and say, please, Mr. Service, write this, and then give me a new write buffer.
Long story short, all of that is just to avoid having to do what Rust did with their borrower, because it's the same net effect. It's just that it would have added too much surface area to the language.
Okay, are you actually living with a single buffer only, or you can have more than one?
Any number.
Okay, fine. So
and it's also designed.
If I say, give me a write buffer, and you hand it to me, and I fill it, and then I say, here, Mr. Service, write this out. But I'm busy writing lots of things, so give me another write buffer.
That's right. Exactly.
And so the service keeps handing me the same buffer, or I get a cycle of 2 or 3 or whatever, and he just rotates them around.
So the idea is you can't tell, but obviously the goal is that it's the same 2 over and over and over.
Yeah, you want double buffered as a minimum, so you want 2. But that's sort of maybe you don't need more than that. And why the kill on the flip for read versus write, other than it just demands I have a buffer sized batching of reads and writes?
When we designed the contract, we weren't worried about 2 readers against the same buffer.
No.
But it's almost never a requirement.
It's the copy guy wants to read once and write once. And the stupidest copy on the planet is I read a byte, write a byte. And maybe I have a little bit of filtering along the way.
Right, but that's 2 buffers, right?
And that's 2, right? But you said as soon as I flipped the contract, I got.
Oh, but each buffer has that contract.
Oh.
So I flipped the buffer.
Oh, I'm sorry. Oh, I see. So if I have 2 different IO streams, I'll get a buffer for each one. But the buffer under the hood is actually mini buffers or 1 buffer. I just can't tell, and I can't cheat and have it be both a read and a write.
Right. So not only that, there's an abstraction behind the scene, which is kind of the buffer manager.
Yeah.
Whose job is each time you ask for a buffer on one end and each time you recycle it on the other, it's keeping statistics because it's trying to determine is the hotspot number 2. Oh,
you actually implemented Dangle here, more or less.
Not yet, but that's the goal.
Wow.
So the contract is designed to allow us to do that. Yeah.
Yeah, sure. Oh, that's good. Awesome.
Yeah, that was like 2 weeks of.
Okay. The NIO has the whole mark, flip, whatever the hell thing, and that was their goal, was to let you have the same buffer be read and write and go back and forth in kind of a reasonable way with the minimal, and it's really minimal overhead, but it's the invariants get really subtle.
Yeah, the mark. I didn't understand why they did the mark.
Oh, I've done it. It's a freebie extra finger for there are things that you want to do fingers with. Like I'm doing a CSV reader, a bulk fast CSV reader, but I have big buffers, but CSV lines the last one always spans half of a line. So I want to copy it to the start. So I guaranteed when I have a line, I can go to the next layer of semantic meaning with a full line. So the next layer of semantic meaning up the chain doesn't deal with partial CSV lines. He only deals with whole CSV lines. And so mark shows up in that kind of context where you ended up with you read the buffer and you had the half and you took the half and copied to the beginning and you started here and then you read again and then you stopped it. Okay, here's the whole line and go. And I'm doing, terabyte size FinTech CSV file data, and it was useful.
Yes, I would prefer for that to be hidden inside a stream representation.
Right. The default stream representation you got from Java did such a poor job of it. And the amount of code involved is like 30, 40 lines. So I have a piece I cut and paste between projects that's really tiny and gives me a 5-fold speed up over standard streams, 10-fold speed up, something ludicrously faster.
Right. What I meant though is that abstraction for the stream. So forget the implementation, which I think sucks.
The abstraction.
But if the abstraction had mark and restore or mark and reset, then because the thing I didn't like about the NIO buffers is that you pay for the mark on pretty much every call. So
I'm sorry. The standard IO, I was going to say the standard IO buffers have the mark thing. There's no paying for the mark. Mark doesn't do anything unless you use it.
Right. So you have limit, offset,
There's a buff base. There's
capacity and mark. So you have four fields.
Right. And mark doesn't participate hardly at all.
Well, except they have to check it.
No, that's what I'm saying. Mark doesn't participate. I don't believe. Maybe.
But anytime you change one of those, it has to make sure that the mark's not out of bounds, for example.
No, I think they let mark go wonky. If you don't touch mark and you don't care for mark and you don't use mark, mark doesn't do anything. It just sits at 0 and it's like in bounds of the buffer, but not in bounds of your limit to capacity or whatever the current point of the capacity. It can be out of bounds.
Interesting. Well, I looked at the Java sources. I don't know if they actually use that though.
Yeah, no, the Java sources are what's used there. The real issue though is actually the time is all getting the data in and out of your caches, and the mark extra word is all hot in L1, doesn't make any difference.
Yeah, that's a good point.
Performance hit that the stream folks pay for is all tied around with not properly streaming through the buffers without actually doing anything with them.
So the other thing we designed buffer APIs for is in zero copy use cases, basically what you're doing. So normally stuff shows up in memory.
Oh, well, let me hit the zero copy. You go first, but I got zero copy strings that I want to bang on you to make sure you get it right.
Okay. So, you get a network packet that comes in.
Yeah.
Right? So where is that packet?
Exactly. It's in some kernel memory first, but not necessarily.
Well, right. So the NIC gets the packet.
Yeah.
And if it supports virtualization and everything, it can actually copy it into your application space directly.
Yes,
right?
directly.
So now it's sitting in your application space.
And high frequency traders do this all the time in Java.
Right. So now you go and you ask, give me the next byte, right? And you know what happens before you actually look here? It copies it here.
Which API?
I'm just talking, say, blocking sockets or pretty much anything.
Yeah. If you're at the socket level, you're probably getting a copy. Yeah.
So you have a socket which has a certain space, but so there's always but if there are ways you can tell it, don't copy it.
Yeah.
Right? Basically, what that does is it blocks the sender. By sending the Windows 0 back. Anyway.
Oh, you're at that level of networking things. There's a Java thing that'll do that, and it's a non-standard hardware that mixes with Java. It's on Solar Flare or on Flare or something like that. It's fine. Sorry, go ahead. Such a thing exists for Java because the HFT guys do it all the time.
So the idea is, though, you want to be able to, when you say buffer at an application level, you don't want to know whether you're working with a copy of the buffer or if you're working with the original one itself, right? You just want to be reading from it. So the concept of zero copy versus not, you want to be able to push that kind of down a level.
I would claim you want to have your string also do zero copy. So when I'm reading these terabyte CSV files, at some point I end up with a pile of strings I do string-like things with, but I shall not copy the 1 byte to 2, and I shall not make the 2 as a new allocated thing for a string, promptly throwing it away, or I will drown the horrible memory bandwidth depth, right? That's my 5x slowdown or more. So I have a string-like thing which wraps over a buffer, which handles the case when the buffer has to wrap and all that kind of shit. And it has to talk to the buffer, and the buffer has to talk to it, but it behaves like a string, except that basically it's just a wrapper over some other big complicated buffer.
So my theory is you can actually, I haven't implemented this, so this is just in my kind of thought process, that it's actually a very similar algorithm to your escape analysis optimization, which is with escape analysis, I've got a stack and I call this and I call this and I call this. And if this allocates something that escapes to here, what I really want to do is say, whoa, next time I run this, make this one fatter. Leave me 16 bytes here. Because I'm going to put the object header here, right? And 2 fields or whatever, right? So now when this one allocates a string, I want to put that string here. Right? In line.
I did this at Azul a long time ago.
In line on the stack, right?
I did this like this was a long time ago. There's some limits to what you can do.
So, but you could do the same thing conceptually. If it doesn't escape here, you can do the same fattening there. So expand your expand your stack frame.
May I suggest that you get into a mode where you can experiment with a lot of different execution running styles before you settle on how you go there? Because I did this for quite a while over a lot of giant Java programs on hardware that was geared for it. And there are some real black holes you can fall into. It doesn't work so cleanly as you'd love to believe. It does. It definitely works. It definitely, when it wins nicely, and you can kill yourself in a hurry. So you want to go down the path right now? It's already 11:40. I want to eat lunch. This is a great one for next time. What can you do with stack-based? I call it stack-based analysis versus stack-based detection. It was, or escape analysis versus escape detection. That amongst the many black holes, you know, with long lifetime objects that need to be GC, but they're on your private stack. So your private stack has to do a foreground GC, which is not as efficient as a background GC where the stack doesn't care because it's not moving fast. And there are arrays and arrays of things that get all escaped all at once that you lazily discover late in life. And there's dozens of black holes I fell into to get that heuristic to run reasonably well. And eventually got it to run to like 70% of a JBoss web server under heavy load. 70% of all objects were allocated and freed on the stack. And that was not good enough to beat the Azul collector.
Do you see the chat?
Oh, there you go. PR to OpenJDK. Nice. Yeah. String zero copy. Yes. For high throughput operations where you want a string-like behavior, you need a zero copy-like behavior. And I have hand done it repeatedly in the Java land. And it's a stupid thing, and it's not very much code. So what the hell? I even touch a class where I hand you the source code that does all this. This is like you want a 2-hour class on memory bandwidth and performance. I'll step you through a stupid way to go do it that does the right thing, and fuck it. This should have been a pull a long time ago. Should have been a JDK thing a long time ago. Shallow copy of a scalar replace Java lang string object. Yeah, I don't know. I only need a string object. That's the key. I don't care to touch strings. I want to deal with all the 1,000 things that string has tied to it. In particular, I have bytes of ASCII data. Thou shall not double them in size to make an official string. Because as soon as you do that, you lost 2x performance independent of all other memory allocation bugs. Typically, you also paid it twice again because you had to allocate it. So you lost like 4 or 5x as soon as you double the strings. You can't do that. And that's anytime you're dealing with large volumes of textual data that is not Unicode, which is 99% of the large textual data on the planet. So I mentioned fintech buffers, but every log file on the planet falls in this category. You're doing log file analysis, give me a string-like thing that does zero copy and doesn't need to deal with Unicode. Fine, transferable. Yeah. Okay, so I'm going to claim victory here as we're well past hour to hour and 45. Array of bytes. I'll have to stare at your code for a while to understand what's doing there. But I believe that you got it right, Cameron. That was amazing that Java did not. Because the code involved was all done at the time of like, they should have done it. Fine.
But if you're designing a language now, does it make sense to have your entire standard library sort of think in slices over arrays rather than the arrays directly so you can pull these zero copy tricks?
I love the question. So what we did is we made slice return an array, and array is a virtual abstraction anyway. So it turns out that I think you can get both for no additional cost. Fingers crossed again.
Okay, that's okay. It is clear that I want a thing that has array-like performance directly available to me. And that means you have to get rid of all abstraction layers and have a pile of bytes that are indexed, typically stride 1, but could be indexed by a number. There's a bunch of useful properties of arrays for performance that you have to have. Now,
right, but you don't want to give those up for a slice, right?
Yeah, I don't want to give them up for a slice. And so I don't know if a slice is, if the slice is as efficient as an array because it boils away, then you're there. And that's fine. The case of a streaming thing is I don't have a begin and the end of the array, and that makes it a slice, if you will.
Right. I think that's one of the mistakes they made in Java streams. is that they use streams both for bounded and unbounded contexts. So I think they shut off the foot on step one.
In unbounded context, there's no beginning and no end, and you don't want an index number per se. Like in H2O, your for loop over the index number was basically a virtual index number, which was reset to 0 for your slice. But you only actually ran code over slices, and of course the system sliced like hell and for looped everywhere in parallel. But you wrote a for loop over a slice, basically, that started from 0 and went to the length of the slice. And you didn't know what your actual line number was unless you asked special. And you didn't care because you were just looking at a slice. Yeah, I think you have to deal with slices. The theory here is that machines aren't getting bigger as fast as data is getting bigger. So the data exceeds the volume of one machine all the time. So right away, you need to have a concept that says, I have more data available to me than I have that will fit in an array on the machine. And I need to have some sort of way of rolling through it. And people do this all the time. You know, this is Hadoop. This is every giant SQL paging thing, whatever. But now giving an efficient representation to roll through slices that I can maybe run in parallel. Maybe pipeline is a minimum because I have IO to bring it in and IO to bring it out. So there's a bunch of places where I can imagine I want parallelism and independent slices. If they were tied to an array in a low cost way, I'd be interested to see that go around. All right. I'm going to call it. We got plenty of meat next time. We can talk about array slices and 0 copy strings to our heart's content next go around. It's fun. As always, I learned a bunch of new things, so I'm excited. See everybody next week.
Bye.
Bye.